So let's talk about how to find the equation of a tangent or normal line to a curve using derivatives. So first thing first, what you need to understand is that the derivative dy dx is simply the gradient function at any point on the curve, or it's simply the derivative of a curve at any point. Now, the derivative dy dx of a particular curve at a particular point x equals x0 gives us the gradient or the slope of that curve at the point x equals x0. And this is symbolically denoted as the y dx. Then you have x equals x0. And this can be read as the y dx evaluated at x equals x0. And that is what we're considering using to determine the equation of a straight line, typically tangents or normals. But before we begin going through some examples, we need to quickly recall our knowledge in coordinate geometry. The equation of a straight line through a point x1, y1 with gradient or slope m is given as y minus y1 equals m multiplied by x minus x1. So this formula is something you want to put at the back of your mind, or just have it copied down, as we will be referencing back to it as we move forward. So let's try and go over some examples. So find the equation of tangent and normal line to the following curves at the given 4 points. So example number 1, consider the curve y equals 2x cubed, oops, I wrote that on that, 2x cubed minus x squared plus 3x plus 1. Then at x equals 1. Perfect. So the goal is to determine the equation of tangent and normal line to this curve y equals that. So the first thing first, we need to determine the y dx, which is simply the gradient function. So differentiating this function, we have 2 times 3x to the power of 3 minus 2. Oops, I wrote 2. 3 minus 1. Then minus 2x to the power of 2 minus 1. Then plus 3x to the power of 1 minus 1. And that's constant. That's a 0. So we have the derivative to be equal to 6x squared minus 2x then plus 3. So this is the y dx. Now to determine the gradient m, or the slope of this curve at x equals 1, then that will be the y dx evaluated at the point x equals 1. And that will be equals to plugging in 1 into this entire expression. That will be 6 multiplied by 1 squared minus 2 times 1 plus 3. And that gives us 6 minus 2 plus 3. And this gives us minus 2 plus 3 gives us plus 1. When we add it to 6, we have 7. So therefore, the slope of this tangent line, the slope of this curve, to make it the slope of a tangent line to this curve at x equals 1 is simply equals to 7. And I'm going to represent that with m. Now with this information available, we can determine the equation of the tangent line at x equals 1. But before that is possible, we need the y value. So what if the point you are given is not a coordinate point? A coordinate point is when you are given the x and the y value. But in this case, we are given only the x value. In this kind of problem, what are you meant to do to determine y? Well, all you need to do is to take that value of x given to you and plug it right into this curve or whatever function is given to you. Whatever value of y you have is your y1. So at x equals 1, y equals 2 times 1 to the power of 3 minus 1 all squared plus 3 times 1 plus 1. And this is simplified to 2 minus 1 plus 3 plus 1. Plus 1 cancels minus 1, and we have 5. as 2 plus 3 result in 5. So therefore the y value when x is 1 is simplified. Perfect. Now this is enough to determine this equation of the tangent line. So since we said the equation of the tangent line y minus y1 will be equals to m multiplied by x minus x1. So x1 will be this and y1 will be that. Perfect. M is 7. So therefore we can mix our substitution. And this becomes y minus 5 equals to 7 multiplied by x minus 1. Then simplify this forward. Y minus 5 equals to expanding this 7 times x, 7 times minus 1. That gives us 7x minus 7. Then I'm going to solve for y. So isolating y, we have y equals 7x minus 7 plus 5 by the time we had 5 to both sides. And finally, we have y equals 7x minus 2. And this is the equation of the tangent line to this curve at x equals 1. And that's it. Now, what about the equation of a normal line to this curve? First, what exactly is a normal line? Since a tangent line is a straight line that just touches a curve at one point, well, unlike tangents, normal line is perpendicular to a tangent line. Okay, when a tangent line touches a curve at one point, then a straight line that is perpendicular to that tangent line at the same point is called a normal line. Well, I have in my video list, and I'm going to leave the link in the description, the relationship between the slope of a tangent line and that of a normal line. But in this video, for the sake of this problem, we are just going to state it. The relationship between the slope of a tangent line and normal line is that the slope of a normal line, m sub n, is simply equals to -1 divided by the slope of a tangent line, t. But the exact relationship is such that their product, m sub n times f sub t, is simply equals to -1. So which means in the case whereby you're given m sub t or you have it, then you can always determine f sub n. And if m sub n is what you have, you can always determine f sub t. M sub n represents the slope of the normal line and m sub t represents the slope of the tangent line. So let me just put t here. Perfect. So let's move on. So we can now determine this equation of the normal line. You need to keep in mind, the normal line is also a straight line, so it carries the same pattern of equation. So therefore, m sub n in this case is simply -1 over m sub t is 7, and that's divided by 7. Perfect. So since we said the equation of a straight line is y minus y1 equals m multiplied by x minus x1, the points still remain the same because it's at the same points. So therefore, y minus 5 equals, but in this case the slope changes because they are perpendicular. That's -1 over 7 multiplied by x minus 1. Now expanding the bracket, we have y minus 5 equals -1 over 7 times x. That's -x over 7. Then we multiply with -1, we have +1 over 7. Now we can multiply all three by 7. Then we have 7y minus 35 equals to -x plus 1. And let's just set everything to be equals to 0. Then we have 7y plus x minus 35 minus 1 equals 0. And finally, we have 7y plus x minus 36, perfect, equals 0. So that is our final answer to this problem. So in case you are dealing with multiple choice questions, it depends on how the answer is left. Sometimes the answer might be left this way by you just isolating the y, by just solving for y. While sometimes, most especially if you are dealing with fraction, it's often left that way. So that's just it. On to example number 2. So let's consider something different this time around. So find the equation of tangent and normal line to the following curve at the given points. So consider the function x squared y plus y cubed x plus 3x minus 13 equals 0 at the points 1, 2. So the goal is to determine the slope, the equation of the tangent and normal line to this curve. This curve we are having is an implicit function or implicit curve. So to differentiate it, the goal is just to solve for the y dx. Then we just differentiate term by term. So let's differentiate x squared y. So let's begin with x squared first. The derivative of x squared is 2x, but y will be treated as a constant, so we multiply by it. Perfect. Then we associate them with the positive sign. The derivative of y is simply 1, and times x squared gives us x squared. Well, we multiply with the y dx, because the y term has to be differentiated with respect to x. I will leave a link to the video as well. I have the video right on YouTube. Then plus the derivative of y cubed, that gives us 3y squared. But we have a constant x, which we assume is a constant this time around. Then since the function of y, we are differentiating with respect to x. Perfect. The derivative of x is simply 1, but a constant y cube is there. We multiply with it, we have y cube. Then multiply by, well, so it's just x, we are not multiplying. Keep that in mind. Then plus the derivative of 3x, that gives us 3. Then constant 13, that is 0. Perfect. Now the goal is to isolate the y dx. So let's leave the terms with the y dx at this side. Then we take whatever left at this other side. So we have x squared, the y dx, plus 3y squared x, the y dx, equals. So right now I'm taking y cubed, 3, and 2xy. So we have negative 2xy, negative y cubed, and negative 3. Now factoring out the y dx, we are left with x squared plus 3y squared x. So, when I take the y dx out of this term, I'm left with x squared. And when I take the y dx out of this term, I'm left with 3y squared x. Okay. So we see I have negative 2xy minus y cubed minus 3. Now dividing through by this x squared plus 3y squared x. Then finally we got the y dx. So the y dx simply equals to negative 2xy, negative y cubed, negative 3, all divided by x squared plus 3y squared x. Perfect. Now the goal is to determine the slope, as this gives us the derivative function at any given point. Since we are given a particular point, we can determine the slope m at that point x equals 1. So the y dx evaluated at x equals 1. So we are considering the value of x. That's what we use to determine the slope or the gradient. Keep that in mind. Don't go and use y. You have to use the x value. So that will be negative 2 multiplied by 1. Well, we are considering the y value because this is an implicit function. Okay, please keep that in mind. If it assume it's an explicit function, that's when you use the x value alone if you are given the 2 points. But this is an implicit function. We are going to use the both points to determine the slope. Okay, so that will be evaluated at x equals 1 and y equals 2. So that's going to be negative 2 multiplied by 1 multiplied by 2 minus 2 cubed, then minus 3 all divided by 1 all squared plus 3 times 2 squared times 1. Perfect. So this is simply equals to negative 2 times 2, negative 4, and 2 to the power of 3 is minus 8, then minus 3. Perfect. Then divided by 1 squared is 1, 2 squared is 4, 4 times 3 is 12, times 1 is still 12. So we have plus 12. So negative 4, negative 8, negative 3. This gives us negative 15. So minus 15, and the addition of 1 and 12 gives us 13. So the y dx at x equals 1 and y equals 2 is simply negative 15 over 13. So m sub t, don't forget, it will be the slope of the tangent, is minus 15 over 13. Perfect. So we don't need this anymore, we can get rid of it. Now at this point, it's easy for us to determine the equation of the tangent line to this curve at 1, 2. Since y is already given, we don't really need to do any substitution just for y. Okay. So now let's determine the slope. So y minus y1 equals to m multiplied by x minus x1. So y minus y1 is simply 2. So minus 2 equals to m is negative 15 over 13. Then x is the variable minus x1 is simply 1. Perfect. So we have y minus 2 equals to distributing the negative 15 over 13. We have negative 15 over 13x. Then when we distribute it with negative 1, we have positive 15 over 13. So just like before, let's multiply all through by 13. So we have 13y minus 13 times 2 gives us 26. Yeah, I got it right, 26. Then equals to, so this becomes minus 15x plus 15. Perfect. So let's set everything to be equal to 0. So we have 13y plus 15x minus 26 minus 15. So 13y plus 15x. So minus 26 minus 15. That gives us minus 41 equals to 0. And this is the equation of the tangent line to this curve at 1, 2. So the goal now is to determine the slope of the normal line. So just like before, to determine the slope of the normal line, all we need to do is to find m sub n. So since m sub n is negative 1 divided by m sub t, then in this case that will be minus 1 divided by negative 15 over 13, which is the same as negative 1 multiplied by negative 13 over 15. So I have to keep the first and flip the other one, change the sign. Perfect. So that gives us negative cancels. We just have 13 over 15. Very good. So therefore, the slope of the equation of the normal line to this curve at 1, 2 will be y minus y1 equals to m in the bracket of x minus x1. That becomes y minus 2, y1 is 2, equals to m multiplied by x. Well, m is given. We have it. 13 over 15 multiplied by x minus 1. So y minus 2 equals, so 13 over 15 times x, that's 13x over 15. Then again times negative 1 gives us negative 13 over 15. And we have y equals to 13x over 15 and minus 13 over 15 plus 2 over 1. So that gives us y to be equals to 13x over 15 negative 13 over 15. Then 15 in that will just give us 30. Perfect. So we have equals to 13x over 15 negative 13 plus 30, that gives us plus 17 over 15 equals to y. And that is our final answer. If you want, you can just rearrange it like we did earlier. That is how to easily and mentally find the equation of a tangent and normal line to a curve. So that's it for this video, and this is your exercise. So feel free to share your solution in the comment section below. Consider the function y equals to 6 minus 2x plus 3x squared, then minus 2x cubed at x equals 0. Find the equation of tangent and normal line to this curve. Thanks for watching. See you in the next video. Bye for now.